Molecular geometry. This is three-dimensional arrangement of atoms in a molecule. Three-dimensional arrangement. Three-dimensional arrangement of atoms in what? In a molecule. Full stop. Molecular geometry. Molecular geometry is affected by its physical and chemical properties. By its physical and chemical what? Properties. Its physical and chemical properties, such as melting at boiling point, comma, density, comma, and the type of reactions they undergo. And the types of reaction, they what undergoes. Now, under molecular geometry, hello. Well, normally the word geometry there means what the shape of a molecule. Are you following? Yes. So we want to be drawing the shape of what? A molecule. Okay, say it in the Lewis what? The Lewis structure, okay, of a molecule. And when you are drawing the Lewis structure of a molecule, now there's what we call the central atom. The central atom is the atom that is at the middle. Are you getting me? When you are drawing your structure. Okay, and for you to determine your central atom, hello, for you to know which of the atoms or which of the elements that will stay at the middle atom, the middle element known as the central word atom, you use element with the least electronegativity. Element with the what? The least electronegativity. If you don't want to use element with the least electronegativity, or you make use of element with the least atom. Element with the what? The least atom. Now, for example, let's assume we have a compound like, let's say ACOF. Let me use this for example. Okay, unlike this one, you can see that how many atoms of hydrogen do you have? One. How many atoms of carbon? One. How many atoms of oxygen? One. How many atoms of chlorine? One. Okay, unlike this one, now that means they all have the same word, atom. Compared to when you have something like the BaCl2, that your beryllium chloride. Unlike this one now, how many atoms of beryllium do you have? How many atoms of chlorine? Unlike this one, which one stay at the middle? Beryllium. Beryllium being at the middle based on it has the least word, atom. Are you following? Yes. So unlike this one now, the atoms, they are all equal. Are you getting me? Yes. For you to now determine which one will stay at the middle now, you now make use of the element with the least electronegativity. How do you determine that? Now, unlike hydrogen is number one in the periodic table, right? Yes. And that's one. It needs one to complete a share, is it not? Yes. That means plus one and what? Minus what? 1. The carbon is how many in the periodic? Is 6, right? Yes. That is 2 and what? 4. Is it not? Yes. That is plus 4 and minus what? 4. That means it needs 4 to complete the share, right? Yes. That of oxygen is how many? 8. Yes. That is 2 and what? 6. That's plus 6 and minus what? 2. So it needs 2 to complete what? 8. Is it not? Why that of chlorine? Chlorine is how many? 9. If it's 9, it's 2 and what? 7. 2 and 7. That is plus 7 minus what? 1. Are you following? Yes. Alright. The plus there, they are the electropositivity. While the minus there, they are the electro what? Negativity. Are you following? Yes. Now, if you check now, your hydrogen is having minus 1. Carbon is having minus 4. Oxygen is having minus what? 2. While chlorine is having what? Minus 1. Which one is the smallest there? It's minus 4. Is it not? Minus 4 there is the smallest, right? And which one is having minus 4? Which is carbon? That means carbon will be at the what? Middle. Bonding to what? The hydrogen, oxygen, and what? And chlorine. Are you following?
No.
Hello. It's okay now. No noise. Now, you understand that I determine the electronegativity.
Yes.
What position is hydrogen in the periodic table?
1.
Is it not 1?
Yes.
That means if it's 1, that means if you are drawing the shares, is it not 1? You need 1 to complete.
Yes.
This one here is known as the valence electron. Or either you call it valence electron, you call it group number. The valence electron is the total number of electrons in the outermost shell of an element. Are you following? The valence electron of hydrogen is what? Is 1. And you need 1 to make it what? 2. Is it not? Yes. So since you need 1, the one that is at home, this one is at home. The one that is away is minus 1. Are you getting me? So this one is sitting at plus 1. You need 1 to what? To complete. Are you following? The one you need is what? Minus 1. This one, the valence electron there is sitting at electropositivity. Are you following? Yes. The valence electron is sitting as what? Electropositivity. Either I call it the valence electron, you call it the group number. Either I call it the valence electron, you call it the what? The group number. Alright. Now in terms of carbon now, carbon is how many? 6. Carbon is 6 now, right? Yes. In the periodic table, right? Yes. If you are drawing the share, the first one takes how many? 2. And the next one takes how many? 4. Are you following? You can see now the valence electron there is how many? Plus 4, right? Is it not plus 4? How many does carbon need to complete this share? Which is minus what? 4. So the plus 4 there is the valence what? Electron, which is electropositivity. Right there is electro what? Negativity. Are you following? Then in terms of oxygen, and oxygen is how many? Is 8. So the first share takes how many? 2. So the next share takes how many? 6. The outermost share electron now is the valence electron, right? Which is plus what? 6. Plus 6. And you need that many to complete. Minus 2. Are you getting it? So this minus 2 now is the electro what? Negativity. Why is the electro what? Positivity. Now the electropositivity there, or the valence electron, is sitting as the group number. Are you following? Unlike this one, that means that my hydrogen is the what group? Group 1. Then carbon is the what group? Group 4. Then oxygen is the what group? Oxygen is the what group? Group 6. Okay. Then in terms of fluorine now. Okay, fluorine is 9, right? If it's 9, the first share takes how many? 2. Are you following? Then the next one takes how many now? 7. Are you following? So the valence electron there is how many? 7. You need how many to complete it? You need what? 1. The electronegativity there is how many? Minus 1. While electropositivity is how many? 7. That means my fluorine is in what group now? 7. Fluorine is in what group? 7 is among the halogens, is it not? Yes. Let's take chlorine for example, which is known as already chlorine is an halogen. Fluorine is how many? 17, right? Yes. It is 17. First share takes how many? 2. The next share takes how many? And the next share takes how many? 7. This one is plus 7. We need how many to complete? 1. So the electropositivity there is not 7. What group is chlorine now? It is the group 7, which is the halogens. Are you following? So I say when you want to determine which element will stay at the middle element is known as the central atom. Are you following? The first thing that you consider is the element with the least atom. Are you getting me? If all of them they are having equal what? Atom, you now use element with the least electronegativity. Are you following? Yes. I do this one as a case study. Unlike this one now, they all have the same atom, right? So with that, they don't know which one will stay at the middle. Then yeah, they don't assume. Are you getting me? Don't assume when you say, okay, let me put hydrogen at the middle, or let me put fluorine at the middle. No. Are you getting me? You must follow the principle. Then unlike this one now, since everything they are having equal number of what? Atom, you now use element with the least electronegativity. Then unlike this one now, comparing these two now, if you see which one has the least atom, it's not beryllium. This one is go ahead. Are you getting me? So the next one, if you don't have to use that, if you are using element with the least electronegativity, beryllium is in what position in the periodic table? Is it not 4? 4. Is it not 4? Yes. It's 4 now. That's 2, right? Yes. It's not 2, 2. Yes. That's plus 2. And minus how many? 6. Minus how many? 6. Your chlorine is how many? 17. That is 2, 8, 7. That is plus 7 minus 1. Minus 6 and minus 1. Which one has 2 more pass? So the lowest number there is minus 6. Are you following? Yes. So that's it. That means my beryllium will be at the what? At the middle. Are you following? Yes. So that's how to determine your central word atom. That is the element that will be at the word middle. And a drawing of Lewis structure. Hello. We have molecules in which the central atom has no lone pair. Hello. We have molecules in which the central atom has no what? Has no lone pairs of what? Electron. And we also have molecules in which the central atom has 2 or more what? Lone pairs. Okay, the lone pair they are talking about is all those electrons. Are you getting me? We have lone pair and we have bond or pair. If you have this something like this now, unlike this one, and this is the bond. This is what? A bond. And this is what? A bond. This bond now is known as bond pair. Are you getting me? Then if you are not having like dot around it, are you getting me? Those dot is known as what? Lone pair. Are you getting me? Now we have, like I said, we have molecules in which this central atom will be having a lone pair. Are you getting me? We also have a molecules in which that central atom will not carry any word lone pair, or will not have any word lone pair. Are you following? Then another thing again, in terms of Lewis structure, please pay attention. Anything that makes you to give the central atom a lone pair, you must balance up everything. Are you paying attention? Yes. Anything that makes you to give the central atom any lone pair, are you getting me? You must balance up what? Everything. And whenever you are sharing those lone pair, are you following? Yes. Whenever you are sharing those lone pair, you don't give to the central atom yet. You first of all give to those ones that are what? Outside. Are you getting me? Those ones that surround the world, the central atom. So if you not have any lone pair left with you, are you getting me? Before you give it to the central world atom, that when you are sharing the lone pairs, are you getting me? If you are sharing lone pair, they normally do the calculation for it. So I'll teach you the calculations. So now when you are sharing the lone pairs electron, you don't give to the central atom first. You give to those ones that are outside. Are you following? If anyone is not left with you when you are sharing, so the leftover now, that is the one you give to the wall central atom. Is that clear? Is that clear? Now, and another thing, when you are doing your calculation for it, yeah, we don't use mass number. You know, if you want to calculate the relative molecular mass, you make use of mass number, right? You say 1 times 1, then plus 12 times what? 1, plus 16 times 1. Are you getting me? Yes. This time around, when you are calculating for lone pairs electron, you don't use mass number. It's a use valence electron. Hello? You don't use mass number, it's a use what? Valence electron. Your valence electron there is sitting as the group number. Are you following? Or the electropositivity. Alright. Now this time around, take down these questions. Molecules in which the central atom has no lone pair of electrons. Draw the shape of the following molecule showing the bond angles. Now, sometimes, hello, drawing of shape and predicting the bond angle is quite different when they ask you to draw Lewis structure. Hello? If they ask you to draw Lewis structure, you just go straight and draw the structure anywhere you want to draw the word, the structure. But when it comes to predicting the shape and the bond angle, you must draw the right shape for the word, for the molecule. Are you following?
Yes, sir.
Are you following?
Yes, sir.
All right. Now the first one. Sorry. It's very often right. It's BC, so you can correct it. Yeah, BE. See, hello, please, no noise. From here, first thing you have to do the calculation first. How do you do the calculation? Make use of the valence electron. Beryllium is in what group? Beryllium is in what group? Group 4. Is it 4 or 2? Group 2. Alright. We have it as 2 times what? 1. Are you following? Chlorine is in what group? Group 7. Is it not? 7 times 2. Please, no noise. 2 times 1 is what? 7 times 2. 14. If you add up these two, you have what? 16 electrons. So this 16, they are the lone pairs electron. The 16 are the what? The one you do, you subtract your bond electron from the low pairs electron. How do you get your bond electron? Pay attention. From here, which one will be at the middle? Beryllium. Beryllium will be at the middle, bonded to what? Chlorine and what? Chlorine. Now take note, in drawing a Lewis structure or geometry, one bond contains 2 Lewis dots. Lewis dot means electrons. Are you getting me? One bond contains how many electrons? 2 electrons. Now this is known as bond electron or shared electron. From here now, how many electrons do you have in this bond? 2. How many do you have here? 2 plus 2 give you what? 2 plus 2 give you what? Then you subtract your bond electron from your low pairs what? Electron. So that is minus what? 4 electrons. 16 minus 4 give you what? 12. So we have 12 what? Electrons. So is these 12 electrons that you are going to want to distribute? Are you following? So from there now, please pay attention. This part is clear, right? Yes. So we have it as 2, 4, 6, 8, 10, 12. Do I have any low pairs with me? I've given us all the lone pair, right? Is there anyone left with me that will give to the central atom? No. That is why it's called molecules in which the central atom has no lone pairs of what? Electrons. Are you following? Yes. Now, this is it now. Supposing maybe it's Lewis structure they ask you to draw. Please pay attention. Unlike this one, you have to balance it up. Balancing it up in the sense that, see this one, you count this one, this is 2, 4, 6, 8. This one is balanced, right? Yes. This one is 2, 4, 6, 8. It's also what? Balanced. Then for you to balance, this one is 2, 4. This one means how many? 4. So this one can decide to share 2. This one will also share how many? 2. Are you getting me? Or you can decide to share like 4 from here. That is 2, 2. Making it 4. That is 2, 4, then 6. You still need how many? 4. If you check this one, it becomes 2, 4, 6, 8. It's balanced, right? Yes. What I mean is that here you have something of this. Cl. If you share this one, it becomes this, right? Yes. If you share another one, it becomes this. Is it not? So the lone pairs electron is there. You still have your 2, 4, 6. So this one is still, this one is what? Lewis structure. Or you can decide to share maybe 2, 2 from here equally. Are you getting me? Yes. So that it becomes 2, 4, 6, 8 is balanced. 2, 4, 6, 8 is balanced. 2, 4, 6, 8 is also what? Balanced. That's Lewis what? Structure. Are you following? Yes. Then when it comes to predicting or geometry, unlike now, there's no longer no pairs with me, right? Then you leave it like that. Hello, you leave it what? Like that. And like this now, the bond angle, we have to predict the bond angle. The bond angle for this one is 180 degrees. Now, the bond angle 180 degree. Why the shape is what is linear? Because it was straight line. Now, hello. I know that you will be asked, how do they got the bond angle? Now, the thing there is no calculation on it on how to what arrive at the word bond angle. Are you getting me? Just like this one now. You guys like they predict, you know the meaning of prediction. Okay, more like assumption. Are you getting me? So on the north, half of a circle, this is a straight line. Half of a circle is what? 180. The down of it is what? 180. So normally people want 180. There are other, just assume that that is how it is. Are you following? Yeah. So in tomorrow's exam, if they still ask you, that's how you give it to them. Alright. So that's the first one. The next one we have BF3. BF3 is called boron trifluoride. Now for this now, boron, what is the valence electron for boron? 2. Is it 2? No. Boron is in what group in the periodic table? Or what position is boron in the periodic table? Is it not 5? Like 2 and 3, right? So the valence electron is that many? 3. So it becomes 3 times what? 3 times 1. Are you following? Plus chlorine is that many? Chlorine is 9 and that is 2 and 7. Now the valence electron is that many? 7. That is 7 times what? 3. So 3 times 1 is what? 3. Plus 7 times 3. 7 times 3 is what? 21. 3 plus 21. That is 24 electrons. Is it not? So from here now, which one will stay at the middle? Hello, please pay attention. Which one will stay at the middle? Boron. So we have it like this. Boron. The bonding to, please pay attention. If it's Lewis structure, listen up. You can just do it like this. Fluorine, fluorine, and what? Fluorine. Are you getting me? Then how many are we subtracting from it? 6. We are subtracting how many? 6. Then minus 6 electron. How many will be left? 18. Will be left with what? 18. 18 electron. That we are sharing the 18, right? Yes. So let's share. We have 2, 4, 6, 8, 10, 12, 14, 16, 18. So supposing it's Lewis structure, you are done with it. Are you getting me? But this one is predicting or geometry. This is not the right shape for boron trifluoride. Are you following? Don't write, pay attention. The right shape for it is like this. We have our boron. Then it goes like this. This is the shape for it. So you have your F. You have F and what? F. So this one becomes 2, 4, 6, 8, 10, 12, 14, 16, 18. Is there anyone left with me? No. Am I giving the central to any low pair? No. So the bond angle for this one is 120 degrees. The bond angle is how many? If it's Lewis structure, no need of you adding what the bond word angle. Are you following? Alright. And if it's Lewis structure, you can still draw it like this. Lewis structure, you can do it anyhow you want to work. Draw it. Are you getting me? Alright. So with this now, the bond angle is equal to 120 what? Why the shape? Anything to is called trigonal. Anything is called what? Trigonal. And if it's theory, it's called what? Trigonal. We have two trigonal. We have trigonal pyramidal and we have trigonal planar. If the lone pair, if the central atom is having a lone pair, it's called trigonal pyramidal. If the central atom is not having a lone pair, it's called trigonal planar. Are you following? So this one is known as trigonal what? Planar. Because the central atom is not having any what? Lone pair. Hello, in tomorrow that they might make it easier for you. You only have to draw the Lewis word. Amen. What's CH4? CH4 is known as what? CH4 is known as what? Alright. Carbon, what is the valence electron for carbon? 4. That's 4 times what? 1. So hydrogen is what? 1. That 1 times what? 4. We have 4 plus 4, which gives us what? 8 electrons, right? So here we have our carbon bonded to, please pay attention. We have hydrogen, hydrogen, and what? Hydrogen. If it's Lewis structure, you can just do it like this. Are you following? Now take note, the only duplex element we have is hydrogen and what? Helium. Are you following? Now, then how many am I subtracting from it? 4. That is 8. 2, 4, 6, 8. That is 8 electrons minus 8 electrons. We give us what? 0 electrons. That means I'm not sharing what? Anything. It's empty. Is it not? Yes. Now, this 2, 4, 6, 8. It's 8 now, right? Yes. So that means it's empty. You are not sharing any word, lone pair. Now, the right shape for your methane is this. You have your carbon. It goes like this and goes like this. Hydrogen, 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 and what? Hydrogen. And the bond angle is what? 109.53. Yeah? Now, we have methane. Bond angle 109.53. Then why the shape? Anything for is called tetrahedrite. Anything for is called what? Tetrahedrite. So that's number 3. So copy that level to the next one. Copy that. And ask you, right? Why ammonia is what? A base. Alright. For this now, let's do the normal calculation for it. So, ammonia is how many? Nitrogen is how many? 3. Is it, sorry, 5? That's 5 times how many atoms? 1. Then plus hydrogen is how many? 1. Times how many atoms? 4. I told you before during our GPC that whenever it's positive, it means that you are subtracting. If it's negative, it means that you are what? Adding. So this is taken as 1 minus 1. Are you following? Yes. So 5 times 1 is what? 5. Plus 1 times 4. 4 minus 1, right? Yes. So 5 plus 4 is what? 9. 9 minus 1. Yes. That is 8 electrons. So for this now, please pay attention. If it's Lewis structure, pay attention. If it's Lewis structure, you can just go ahead. Guys, nitrogen will be at the middle, right? Go towards hydrogen, 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 and hydrogen. Are you following? And then you are subtracting how many? This 2, 4, 6, 8, right? So minus what? 8 electrons. Are you following? 8 minus 8 is what? 0. 8 minus 8 is what? 0. That is 0 electron. Are we sharing anything? No. Because it's already what? Complete. So this time around, this is what Lewis what structure. You can now do something like this and place your plus. Why are you putting that? Because there is an ion there, right? Yes. So you must bracket it and put what plus. The one we be doing, are we be bracketing it? No. Because there is no radical, there is no charge. Are you following? Yes. Alright. If you are having like 2 plus, you still put what? 2 plus. It simply means that this compound lose 2 what? Lost 2 what? Electron. Are you following? Alright. So like this is what Lewis was structure. In Lewis, if you like, do this like this. H, do the other. It doesn't matter. Are you getting me? Then when it comes to shape now, you can see that it's 4. Whenever it's 4, it's tetrahedrite. And this is the shape for what? F is known as what? Hydrogen fluoride. HF, that's number 6. So yeah, hydrogen is what? 1, right? Times what? 1. Plus fluorine is how many? Fluorine is how many? 7 times 1. So 1 times 1 is 1 plus 7 will give us what? 8 electron, right? So hydrogen bond with what? Fluorine. So we are subtracting how many? We subtract what? 2. That minus 2 electron. Okay. So from here now, so how many is left? That is 6 electron, right? So then we are sharing 6, is it not? It becomes 2, 4, 6. So that's for that. Unlike this one, there's nothing like shape or what bond angle for this because it's just 2 what? Elements. So this one is your normal Lewis what? Structure. Alright. So this one is molecules in which the central atom has no what? Lone pair. If you observe, is there anything like central atom here? Is there anything like central atom here? So that is why there is no shape and what? Bond what? Angle. Alright. So copy that. Let's move to molecules in which the central atom has 1 or more lone pair. Sorry, 2 or more. Trigonal pyramidal. Then what about CH4? What the bond angle? For this one, what the bond angle? 109.5. And what the shape of the two? Tetrahedral. Is it